Alright, everybody, this is chapter 2.7. This will be solving equations in one variable. Basically just solving rational equations. It does say inequalities. Don't worry about that for chapter 2.7. That is for 2.8. So let's move on here. So anytime you're solving a rational equation, there's basically two ways you can do this. You can either clear the fraction, or you can essentially just get one big fraction with one giant common denominator. It's basically whichever method you prefer. You can see there's some questions that, the method, it works best for others. There's some of you might, find a method that you really like and just stick with it all the time. I remember personally when I started doing this, I actually was the one that got a common denominator and then just, as one big giant fraction and then solve it that way. However, I also do like the clearing the fraction way, but I'll show you both ways right now. Where's my thing at? Okay, so solving this one out here, I am going to, let's go ahead and do one big fraction for this one. So as you can see, we got 2x, over x minus 1 plus 1 over x minus 3 is equal to 2 over x squared minus 4x plus 3. Now, as you can see, we can't really add anything over here to get one big fraction, but we can manipulate these in a way that we could. Again, remember, like anytime that you're adding or subtracting fractions, they have to have common denominators, and a lot of times what we would do to get those common denominators that we would multiply, like say if we were adding 2 over 4 times 1 over 2, we would just multiply the 1 over 2 by 4 over 4 and get our common denominator. It's the same concept for this, except we're dealing with multiplying linear factors. So let's go start here. So we got 2x over x minus 1 plus 1 over x minus 3. In order to get a common denominator on x minus 1 with x minus 3, we would basically have to multiply this x minus 3 over x minus 3. Because again, the bottom part here would give us x minus 3 basically times x minus 1. And then the top there would give us 2x squared minus 3x. No, minus 6x, excuse me. Then on this side, we'd essentially multiply it x minus 1 over x minus 1. Again, we are multiplying basically x minus 3 and then x minus 1. Essentially, we're just multiplying it in order to get this common denominator down here. Then you would basically be adding x minus 1, and then it'd be x minus 3 times x plus 1. And then now, since we have these common denominators down here, we can now add the top part and get ourselves a big giant fraction. We'd get ourselves 2x squared minus 6. Actually, we get 5x, excuse me. 5x minus 1 all over x minus 3 x times x minus 1 is equal to 2 times x squared minus 4x plus 3. Now you see here, now we essentially just have one big cross-multiplying problem. However, there is one thing that we can do with this. If we factor this x squared minus 4x plus 3, we can see that, hey, look at that. It basically factors into what we had on this side here. So what we can do with that is we can essentially multiply either on top over here or on top over here. Doesn't really matter, but essentially what we're going to do, multiply both sides on top by x minus 3 times x minus 1. That basically just cancels both of the denominators out, and we are left with 2x squared minus 5x minus 1 is equal to 2. We notice that the square is a quadratic, so we want to set it equal to 0 in order to solve for it. And that's our quadratic. Now I'm going to pause it and write out my solutions for it. Again, I'm going to have you guys work this out yourselves, because again, at this point in the pre-calc careers, you should know how to solve a quadratic. So I'm going to pause it, let you catch up, and then we'll come together. Alright, so as you can see kind of down in this little chunk right here, I have solved the quadratic, and I've gotten the answers the solutions x equals negative 1/2 and x equals 3. Now you might be saying to yourself, oh, I'm satisfied, I am ready to move on to the next question. Hold up now. This is the section that we would talk about, that we introduce a concept called extraneous solutions. Now, extraneous solutions, there's going to be times where you get a solution that doesn't work. That you somehow will get the solution, x equals this number, x equals that number, but when you really plug it in and try to work it out, the number just doesn't work. And basically, again, we do that by essentially just plugging the number back into the original equation. So I'm going to pause the video again and then just plug these numbers back into this original equation here to see what I can get while I pause it, and you should pause this video and do the same thing and see what you get. Okay, so if you kind of notice at the top here, I'm going to put a little star up here by it. If you notice at the top here, I have plugged in x equals 3 to our original equation, and also I plugged in x equals negative 1/2 into our equation, into the original equation. Now, one thing, if you notice, you plug in x equals 3, especially for if in x minus 3 on the 1 over x minus 3 right here, you're going to get 1 over 0. And then we also determine that x minus 3 is also a factor of x squared plus minus 4x plus 3, so that basically is telling us that if we plug in 3, we're going to get a 0 for this. So basically we're left with 2 zeros in the denominators when we plug in x equals 3, so that basically is telling us that x equals 3 is extraneous. And you can't have those, again, that's something that's going to happen. You're going to get zeros in denominators, and when that happens, it's extraneous. Now over here, I did a little simplifying. We had did a little simplifying for x equals negative 1/2. So far, we're looking okay. I'm going to go down here and simplify it a little bit more. We're going to be left with, well, if we do this, that'll give us positive 2/3. Again, 1 over a fraction, just flip the fraction there. Also, this negative over negative becomes a positive. Minus 2 over 7. And this will be equal to 2 times 4 over 21, which is equal to 8 over 21. And now adding and subtracting fractions. Let's see, 3 and 7 have a common denominator of 21. Do this 7 over 7, 3 over 3. That'll give us 14 over 21 minus 6 over 21. And look at that. It comes out to be equal the same. So we know that x equals negative 1/2 is our actual solution, while x equals 3 is extraneous. Alright, so moving on to the next one. Now I'm going to do this in the other method, where you essentially just find yourself a common denominator and then multiply that essentially by the entire equation, both the left and right side of the equal sign. So then if we look at our denominators here, we have an x plus 2, and then an x squared plus 2x. Well, we know that if we factor x squared plus 2x, we're just left with x times x plus 2. And we already have an x here, we would have to multiply that by x plus 2. We have an x plus 2 here, we just have to multiply that by x. We can then say that our common denominator is x divided by x plus 2. Then what we would do is we would multiply the entire equation by x times x plus 2. Then we distribute it out. If we multiply x times x plus 2 by the first term, the x's cancel out. We would be left with x minus 3 times x plus 2. Multiply it by the second term, x times x plus 2. The second terms would cancel out. We would be left with plus 3x. And then if we did that to the second one, well, the entire bottom and the entire top would cancel out. So we'd be left with plus 6. And then if you do it with a 0, and then anything times 0, you still would do it to the other side of the equal sign. Even if it's 0, you would still multiply it by 0, because sometimes there's going to be a little something over here that you need to multiply it by, and then you're going to have to do it. But if it's 0, it's just going to be equal to 0. Then multiplying all this out, we get x squared, let's see, minus 3x plus 2x. We're going to be left with negative x plus, minus 6. That's going to be just plus minus 6 there. Plus 3x plus 6. Negative 6 and 6 cancel each other out. X squared plus negative x plus 3x. That'll give us an x squared plus 2x equal to 0. And again, quadratic. You should know how to solve these by now. Again, just factor out the x here. You get x plus 2 is equal to 0. And then we would set both of them equal to 0. And then we'd have x equal to 0. And then, darn it. Hang on, I'm going to pause the video real quick. Sorry about that. Computer is being, dumb. So anyway, we got our x equals 0 and x equals negative 2 solutions down there. Again, we need to plug both of these in. We need to plug these in, and if we plug them in immediately, well, if we plug in x equals 0, well, this first term, if we plug a 0 into that one, it's just going to be negative 3 over 0. And then if we plug it into if also we plug it into the third term, it's going to be 6 over 0. So we know that 0 is extraneous. I'm just going to write extra there. And then if we plug in a negative 2 there, well, our second term is going to be 3 over negative 2. And if we plug in the negative 2 to our third term, we're going to get 6 over, well, that's just going to be 6 over 0. So both x equals negative 2 and x equals 0 are going to be extraneous solutions. And one last thing, I basically up here, I'm going to put a little star up here by it, above the solve bar kind of here. I basically just kind of did a visual representation of if I had plugged in x equals 0 and then x minus 2. Again, we plug in again, the first term would be just a negative 3 over 0, and then the next term, and then the third term here would be a plus 6 over 0. And then if we plugged in a negative 2, we'd get a plus 3 over 0 for the second term, and then a plus 6, 0 for the third term. So again, when both of those happen, that means that both of your solutions are extraneous. Again, that's an extraneous, kind of an extra for extraneous. Now that can happen. There are going to be times where both of your solutions are extraneous, and nothing we can do about that. But again, in these solving rational equations problems, it's not good enough just to find the solution and just be done with it. You have to check your answers before. You should have been checking your answers before, and you could have slid by not checking them. But now when doing these problems, it is imperative, and I cannot stress that enough, it is imperative that you check your answers to make sure that none of them are extraneous, because some of them might be extraneous, none of them might be extraneous, all of them might be extraneous. But again, that's something you need to check for. And that will conclude this video.